They could track the behavior of your walk and tie you to your data set and AWS and how you shop and all this kind of, it's like wild, deep data aggregation stuff. And that just blew my mind. And I knew how antiquated some of the oil and gas technology was, but I knew there was a reason for it. And one of the main reasons was it's really hard to put everything in classified areas, right? You have a classification problem in oil and gas that holds back a lot of technology because it becomes cost prohibitive and doesn't make sense for the wellhead. So that's where cameras started to make a lot of sense because you could get cameras positioned outside of classification areas. You could still do a lot of cool tech with them. And anyway, so as we progressed, we talked to our buddies over at Extraction at the time and said, hey, how do you guys find leaks now? If this is a serious problem, you guys are looking at setbacks, and it was Proposition 112 was the name of the big thing. And you need to prove that you're not leaking and things like that. Like, how would you do that now? And they started telling us about LDAR. And that's the first time I'd ever heard that term in my life. And so they gave me Mark Fishburne's phone number. He was the global key accounts manager at FLIR at the time. So I called him. I was like, hey, man, I want to build a software that automates LDAR. And he's, what? But he was actually really bullish on it because he had seen that vision before. And anyways, so he loaned us a camera. We got started. At the time, it just so happened that we had family friends that were in computer vision and could help us. And it just started to come together. And this is a long origin story, but that's really how it happened. Is a bunch of really, I don't know if you want to talk about cosmic alignment or divine appointment or however you want to say that, but a lot of things clicked and came into place right at the right time. And we were able to produce a proof of concept computer vision model that could detect fugitive emissions in about 90 days. From whenever we said, hey, this is a problem to solve, to our first proof of concept, it was a 90-day to maybe 120-day process where we had definitive proof that this concept could be accomplished. And so that was a huge win. And it took a lot of different people to come together to make that happen. And that was it, right? So we started showing that to producers and they saw the vision. And then all of a sudden there was a camera on a facility. And then we began to really understand the implication of putting a vision system on an oil and gas facility and all the other things that we could see, tank levels and smoke and fire and all these other things that were really important as in inspections that needed to be done, or really like emergency situations could be. And our first customer saw that same thing and said, wow, we can do a lot with cameras actually. And it tore down that classification problem, the running wire all over a facility and putting sensors everywhere. And that was what kind of held a lot of people back. And I was like, oh no, it's one wire. And the sensors just happens to see everything. You put it out there, you run wire, you run power, it's outside of classification, you start scanning your facility. What all can you see?